Okay, back to the notes here. 9-6. Hit the wrong button after the warm-up right there. So I want you to go back up to the top. We can white out this section. If we were in class, we would have used algebra tiles, and we could kind of relate that to what we're doing right now. But we didn't use that, so all we're going to do is just figure out if something's factorable. Okay, so it says, is it factorable? Can you factor everything? Does everything have a solution? And the answer is no, not everything has a solution. Okay, if I try to factor this, what multiplies to 2 and adds to 2, well, nothing's going to work there. You might think that, well, 1 and 1 times 1 is going to be 1, so that's not going to work for the top portion here. And you might say, well, 2 times 1 is 2, and well, but 2 plus 1 is going to be 3. So that's not going to work. It's not factorable. So not everything is basically going to be a rectangle. So if I have area equals length times width, not every problem that I'm going to get is going to work out where I can factor it. Okay, so sometimes you can try to factor it, but this is just not going to work out. Okay, and what would that look like in a graph? Okay, well, if I were to graph this, we kind of just learned about that in the previous example, but if I were to graph it, sometimes it has no solution. Like this never touches the x-axis. We learned that the solutions are where it touches the x-axis. This has 2 solutions, right? Just this graph that I made up here. And this will be another one with no solutions. It has no roots. It never touches this x-axis. For something to have a solution, it needs to touch this x-axis. So not everything has a solution. So we need to know that before going into 9-6. So far, everything that we've done in 9.1 to 9.4, they have solutions. All right, so what happens if something's not factorable? What can you do? Well, you can use the quadratic equation. Okay, so this is the last method that we're going to talk about. We talked about graphing, we talked about factoring, we talked about square root method, and now we're going to talk about the next method, which is the quadratic formula. Hey, if you are really interested in how the quadratic formula works, I'm going to put another video on here deriving the quadratic equation from standard form. In class, we would probably spend about 20 minutes doing this. I'm just going to link a video that would do the exact same thing that we would do in class. Okay, so basically you're going from ax squared plus bx plus c equals 0, which is standard form for a quadratic equation, into the quadratic formula. Okay, and the quadratic formula is going to be x equals, and I'll sing a little song here. We would sing this in class. It goes like this. It's the pop goes the weasel song. So it goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we would kind of sing that, and that's a good way to remember it. If not, you guys are learning at home, you can just write the formula down and use it for all of your problems. Okay, the first thing we need to do is we have to identify A, B, and C on all of these problems. Okay, so just like we would do when we factored, we identified A, B, and C. Well, we're going to use that in the quadratic formula. And this arrow that I drew here, this represents about 6 or 7 steps that you'll see in the video that's linked. So it is possible to go from here to here. And if you're thinking about it, you might say, well, I have an x squared right here and I have an x right here. How could I possibly solve for just one x when one of them is squared and one of them is not squared? Okay, and that'll be explained in the video. Not something you necessarily need to know how to do. You just need to know how to use the quadratic formula. All right, so let's try a couple of these. It says solve each equation with the quadratic formula. Well, I'm going to identify my A value, which is 1, my B value, which is negative 5, and my C value, which is negative 14. So you need to put it in standard form first. So must be in standard form. I'll write that up here. So must be in standard form before you get A, B, and C. So my A value is right there, 1. B value is negative 5. And my C value is negative 14. Let's use a different color there. C value is negative 14. Okay, then I'm always going to write out the quadratic formula. I'm going to write x equals negative b plus or minus the square root of b squared minus 4ac. All of this is in the square root, all over 2a. And I will shrink this up. And I'll just fill in my values. So I have negative 5 for b, and I also have a negative in front there, so that's a negative and then another negative. That's going to turn into a positive, plus or minus b squared, so negative 5 squared, minus 4 times 1 times negative 14. And then I have all over 2a, which is 2 times 1. Okay, and then I'll just white that one out, get some more room. I'm going to write x equals, keep simplifying here. This is going to be 5 plus or minus. Negative 5 squared is going to be 25. And then I have negative 4 times 14. So that's going to be a positive right here. And 4 times 14, you can just do it off to the side if you're not sure. It's going to be 56. And then I have 2 at the bottom. And I'm just going to keep going step by step. So I have 5 plus or minus 25 and 56. So I'll add those together and see if that's something I can take the square root of. Okay, so we can just keep adding here. And I get 81. Okay, so I have 5 plus or minus 9 divided by 2. Okay, now it's time to start shrinking this stuff up. Okay, now that I have that, I'm going to do both the plus and the minus. So I have x equals 5 plus 9 divided by 2, and I have x equals 5 minus 9 divided by 2. So the plus or minus part means you have to do the plus and the minus. So this is going to be x equals 5 plus 9 is 14. 14 divided by 2 is going to be 7. So one of the solutions is 7. Okay, over here, I get 5 minus 9, which is negative 4 divided by 2. So the other solution is going to be negative 2. Okay, so I got my 2 solutions. Now it's important to relate a couple things here. So first of all, this could have been factored. All right, factoring would be much quicker. So if something can be factored, you always want to try to factor it first. Okay, so for instance, if I go back up here, I'm going to kind of erase all this stuff. I know my solutions here are x equals 7, x equals negative 2. So I'm just going to delete all this stuff and show you that you can factor it. I'm also going to show you that you can graph it. Okay, so when I try this here, if I factor this, what multiplies the negative 14 and adds to negative 5, that would be a negative 7 and a positive 2. Okay, and then I could factor that into x minus 7 times x plus 2 equals 0. And my solutions would be x equals 7. And my other solution would be x equals negative 2. Okay, a lot shorter. We got those solutions right here. So those solutions would be in yellow. So if you can factor it, always try to factor it. But sometimes it's not always factorable. Okay, I could also graph this in Desmos. So if I were to graph this, just to show you that there's different ways to solve it and you get the same answer, I'm going to type in x squared minus 5x. It says m, I'm just using x, 5x, and then minus 14. Okay, equals, I can put y there if I wanted to. Oops, erased it. So this is going to be x squared minus 5x minus 14. Okay, I meant to do that. There we go. So if I click on these, I can see that the solution's graphing would be -2 and 7. All right, so we actually just solved it 3 different ways. We factored it, we used a quadratic equation, and we graphed it. We got the same solution. Okay, let's do one more problem here. Let's do